Dominic, welcome to the stage. Thank you.
Thank you for that introduction, Ruth. Yes, as Ruth says, I'm Chief Architect at ESRI UK, and that means I get to spend a lot of my time working with organisations such as yourselves, building platforms for managing and analysing spatial data. And I guess what I really wanted to talk about today was the importance of spatial data. So as well as being an architect, I'm also a geographer, and I believe that the kind of spatial aspect of data and the analysis that goes with that is incredibly important, which is why I was so excited and happy. You know, how happy I was to see the previous two presentations both included maps and spatial analysis in some of the examples of the work they were going on. Spatial analysis falls within all sorts of areas. I mean, I noticed the spatial distribution of you guys has kind of moved back a bit. We've spread out a bit from the previous presentations. So I'm a geographer, and I want to talk a little bit about spatial analysis and some of the things that are happening in the world of big data and machine learning that are impacting spatial analysis. And when I say I'm a geographer, what does geography mean? So this is a dictionary definition of geography. It's the science that studies and describes the Earth, its physical, biological, political, economic and demographic characteristics, and importantly, the interrelationships between them. Now, this is probably a definition written by a geographer. It's fairly all-encompassing. We all like to think that, you know, our science is the most important, the most far-reaching science. Now, I wasn't always a geographer as a child. I wanted to be an explorer. You know, I'd see the epic, the exploring adventures of some of our historic explorers, but I kind of realised I was born probably a century too late to be an explorer. So I went into the field of surveying. That seemed like the next best thing. I could travel around the world, explore the world, do seismic surveying. But what I actually discovered in that industry is that I probably spent most of my time sitting in a room with no windows in the bottom of a boat somewhere in the North Sea looking at statistics and maths and running algorithms. And that wasn't really the kind of exploring with a Panama hat and a machete hacking my way through the jungle that I was kind of interested in. But it did highlight the fact that if you want to understand the world today, it's going to be about data. Most of the ways that we understand how the world works, where things are, is all about data. And today's explorers kind of understand the world by accessing that data. Now, that data might be sense data coming from satellites that have been sent up specifically to capture that data, but there's huge amounts of other data sources. And many of those data sources have a spatial element, whether it's the location of your smart meter, whether it's the location, the telematics from autonomous cars, your phone as you move around. An awful lot of the data that we collect and use today to model what the world looks like has a spatial aspect to it. And organisations are increasingly using that data to understand their business, the reach of their organisation, the assets in an organisation with more and more precision. So whether that's farmers understanding each individual potato plant in a field so that they can better manage the delivery of water or fertilisers, from forestry who used to manage forests at kind of huge blocks, they're now looking at understanding their holdings at the individual tree level, understanding the kind of the growth and when things are ready to be harvested. So that precision and the sensors that we now have for collecting data has meant there's been a huge explosion in the amount of spatial data that we collect and the amount of data that we need to use to, in our analytics to make decisions from that data. And when you look at any kind of list of kind of current trends in technology or trends in various different industries, there's lots of different lists and they all have kind of varying things on this. It's just a fairly random selection, but you'll see that most of these are driven by big data. They either generate big data or they're powered by big data or they rely on big data for analytics. So whether it's smart meters, Internet of Things, kind of smart cities. All of these things are generating huge amounts of spatial data. And there's another trend, the so-called digital twin, which we're beginning to see in areas of manufacturing and operations. And the digital twin concept is not some kind of high-tech sci-fi doppelganger or personal assistant. It's not a digital twin standing up here talking to you while I sit at home watching the cricket. A digital twin has come out of the manufacturing industry, and it's about building a model of your real-world assets. And typically, a jet engine, for example, the digital twin of a jet engine may live in, Rolls-Royce somewhere will have a digital twin of every engine that's sitting on an aeroplane that's flying around the world. And that digital twin is a model of that engine, but it's not a static model. It's not like the CAD drawing that was used to design that engine. It's a live model. It's connected to sensors on the asset. It's connected to all the sensors in the engine. It receives all of that data. And it's not just about monitoring. It's also about making predictions. So once you've got the model and the data and the sensors that are updating that model in real time, they're able to make predictions about which aspects are going to need replacing soon. Does the maintenance schedule need to change? Do they need to do something about the flying hours to extend the life of a particular asset? And when you think about that for manufacturing, you can imagine taking that same concept and extending it out to the real world, to the cities that we live in, the ecosystems, your organisations. If you go to the control room at TfL, you'll see a good example of where that's going. Lots of sensors feeding real-time information from traffic sensors, from traffic lights, from buses, from trains, from underground trains. So you're beginning to see much larger organisations build these kind of digital twins of the real world. And the real power of them is not the collection of that information or the monitoring of that information. It's about being able to use that information to predict what's going to happen next. And a lot of that information has a spatial aspect to it, which I guess brings me back to geography and the relationships between things. So the first law of geography, everything is related to everything else, but near things are more related than distant things. And actually, spatial analysis is about understanding those relationships and then using those relationships to make decisions and to predict what's going to happen in the future. And when we think about spatial analysis, there's a wide range of things that you can do as part of that analysis. We saw some examples earlier on where some analysis had been carried out to find some locations and then displayed as maps for users to interact with. So, starting on the left-hand side, there's some simple analysis which is really about understanding what your assets are. Where are your assets? How do they compare to where they were last year or 10 minutes ago if it's a train or a bus or mobile phone? So being able to just visualize where those assets are is the kind of first step. The next step in spatial analysis is thinking about, well, tell me something about those assets, those customers. How much are they spending? That particular bank branch, how much capacity does it have to serve customers? What's the size of those things? And then you get more interestingly as you move across the slide, how are things related to each other? Which branches on high streets, do they do better than branches near stations, for example? What are the relationships between things? Where is the closest depot to my customers? The next kind of type of spatial analysis would be about, well, how do I connect those things together? How do I route my delivery trucks to my customers? How do I best position my warehouses so that I can save fuel when I'm delivering parcels in certain areas of the country, the best paths? And then we get to the real kind of science bit, which is about looking for patterns, statistics. What are the statistically significant hotspots of crime or of health deprivation? Once I kind of understand that, I can start to do the really valuable thing, which is about predicting what's going to happen. If I turn this dial on my city, what difference is it going to make to the traffic flow? What difference is it going to make to people's commute times? What difference is it going to make if I change how I'm distributing power across my smart grid? I can start to make those predictions because I've got information about where things are and how they're related and what's the statistical correlation between those things. So spatial analysis encompasses all of these things, and many organisations are using these methods to analyse their existing assets, their existing data. So just a few examples. So we've got a workshop later on today where Dave's going to go through some more detailed examples and some of the kind of processes and tools that you can use to do this. So hopefully that'll be quite interesting to go along to later. You know, from simple displaying maps of where things are, what things are going to affect if I want to build offshore energy plants. You know, shipwrecks on the floor-bed are quite important to the location of where I put things. So that's, you know, a fairly simple where things are problem. This is a more how am I going to, what's the best way to distribute things to my customers? How do I route them? What's the best order? How do I pack my lorries to make sure that I deliver things in the right order? What time can I guarantee to my customer that I'm going to arrive? What's the window for delivering things? Where do I locate my, I think in this particular example, it's click and collect lockers. Where should I locate those lockers to best serve the customers that I have? So this is about looking for statistical anomalies in healthcare. So this is low birth weight. Where are the hot spots? How does that relate to my provision of healthcare? So the dots on the map are the kind of healthcare provision, and it shows how those are distributed in relation to areas with where children are born with low birth weight. So this is a much more kind of analytical view, looking for statistically significant hotspots. And finally, prediction. There's lots of ways of running and building models to predict based on data, which I think Dave might go through some of these later on. This is using R to combine GIS data with some predictive models to look at how things would change over time. So these are all kind of classic spatial analysis methods that people have used for many years for analysing data. And I mentioned at the start we have a lot more data these days, the challenges of big data. And really, the big data challenge, for me as a technologist who builds systems, the big data challenge is quite interesting. We get to play with lots of crazy new technology. We get to use Hadoop and Spark and all these things that everyone gets really excited about. But for people trying to make decisions, that should be almost irrelevant. The types of question that people want to ask remain pretty much the same with big data. They're able to ask them about in much more detail, in much more precision. They're able to ask those questions and use all the data to power the answers. But the kind of underlying technology and tools should remain fairly kind of insignificant to the users trying to make decisions, to the analysts trying to build the models. But one of the things that big data has led to is it's starting to power some changes based on artificial intelligence. And, you know, like many trends, you can kind of track how excited people are about these trends. And you can see that over the last year or so, deep learning, machine learning, artificial intelligence, there's been a big uptick in kind of understanding what that means. What does that mean? And so I just want to cover a little bit about what's happening in the geospatial world with regard to some of those things. So one of the big challenges, I'm only going to talk about one of the challenges. So one of the big challenges in artificial intelligence is computer vision. Now, for you and I, it's relatively easy to tell the difference between a chihuahua and a blueberry muffin, or a labradoodle and a piece of fried chicken. At least in a photo, it's relatively easy to tell the difference. But this is actually an incredibly hard challenge for a computer to be able to understand the differences between these photos. We've been able to learn how to distinguish those. You know, even a child would be pretty good at distinguishing these. You're probably thinking, what's this got to do with geospatial analysis and spatial analytics? So in the last couple of years, technology has moved on hugely in the areas of image recognition, particularly with the use of deep neural networks, convolutional neural networks for image recognition. I'm not going to go into the details of how all that works, but the combination of huge amounts of data and really massive computing power for processing that data and training models has meant that in the last year or so, computers have got as good, if not better, than well-trained people at understanding the content of images. They don't necessarily understand the intent of the image, or, you know, did one of those chihuahuas look happy or sad? computer would struggle with that, where a human might be able to tell, or at least a Chihuahua expert may be able to. So one of the big areas that's driving this, as well as kind of the social media, is this a photo I've just taken of my Chihuahua or my breakfast? Also, autonomous cars have been driving some of the advances in computer vision. It's very important for autonomous cars to be able to understand the world around them, to be able to understand, is this thing that I can see over here a car? Is it a person? Is it something hard that I don't want to hit? Is it something squashy that I probably shouldn't hit? So there's been a lot of advances driven by autonomous vehicles. But one of the really interesting things is you can take those same models, that have been trained on huge amounts of data, you can take those same models and apply them to the Earth observation challenges. So this is a typical multispectral image of, this is actually of our headquarters in California. And typically for many years we've been capturing information, but it's been quite hard to analyse. We can analyse it at a fairly broad scale and generate models based on that, looking at land cover, for example. So on the left is a map, I guess a traditionally remote sensed map of Chesapeake Bay. And using traditional models, it's very hard to be very precise about what a certain part of the world looks like. But when you start to use a deep learning model, take that same data, train a model to understand what those pixels mean, what those patterns in the ground mean. Is it a building? Is it a road? Is it a certain type of vegetation? You can generate much more detailed models of the real world that can be used by organisations. So in this case, they're able to generate very localised, very focused management plans for their environment because they have much more detailed data that's been built by machine learning algorithms. Facebook did a really interesting project. One of the real challenges of understanding population, certainly in countries where collecting that information is very haphazard, particularly in rural areas. Facebook have a project where they're looking to give the internet to everybody so they can share their pictures of chihuahuas and blueberry muffins, but also for humanitarian reasons, for delivering aid, for delivering services, for kind of understanding a population. So on the left is the kind of traditional population map where you would kind of look at big urban areas and you'd be able to figure out roughly what the population might be. But when you come to rural areas, getting that detail is very difficult. The population's spread over many tiny little buildings, very small villages of 4 or 5 buildings. And Facebook were able to use machine learning algorithm with satellite imagery to generate a very detailed population map of the world. And it's being used by the World Bank in several countries in Africa now to help target and understand the population that needs to be serviced by their services. And that's being driven by machine learning. You can sign up today for a service if you're running a shopping centre, for example, and you want to know how well your competitors are doing. They're not going to give you that information. Satellite imagery is available on daily for most of the globe these days, and you can sign up for a service where an artificial intelligence system will count the number of cars that are in a certain shopping centre and make predictions about footfall within there and therefore revenue. And you can get daily updates from that service. Again, powered by machine learning. On a similar vein, understanding the world's oil supply. If you're a commodity broker and you're buying and selling oil, it's really important to understand how much is out there, how much is in storage, how much is in transit. You can sign up for a service that uses artificial intelligence to firstly identify where all the storage tanks are in the world. They're quite easy to identify, actually. They're quite round, and machine learning are very good at picking out those types of things. But then it takes it a step further. It analyses the shadows on them to understand how big those tanks are and how full those tanks are by the internal shadow. And again, you can get a weekly update at a global scale. Now, clearly, a person could sit down and calculate all that, but the ability to do that on a global scale is kind of game-changing for that level of data. Right, so we're sort of coming up to the end of the 20-25 minutes. So there's lots of things that you can do with spatial analysis, machine learning, big data, all those analytical techniques. But I guess the most important thing is all of those things are just They're just tools, and using the tools on the data. Artificial intelligence isn't able to decide what the best way of using that data to make a decision is. That's down to an analyst who knows what the techniques are, who knows the data and understands the business. So it's still incredibly important to have a human in the loop, somebody who understands the problem, who's able to address the problem, and who understands spatial analysis. The tools and the data will support that person, but they're not the key thing. The key thing is that understanding of how important the spatial aspect of data is. So we've got a session later on where we're going to go through some of those tools and techniques. So please come along to that, and we'll kind of have a look at that. But so I just wanted to kind of finish on, the spatial aspect of most data that we collect is incredibly important, and the ways that you can analyse that, use maps, and to visualise that and present that to your stakeholders, I think, as we've seen in the previous presentations, is also incredibly important. Okay.